All right, friends and neighbors, now we love wireless and we're never going to give it up. We just can't go back. And in the last couple of videos, we've been talking about how wireless networks work. But in a couple of those videos, I did sort of denigrate or run down wireless networks based on their performance characteristics. Well, today I'm going to show you why I said those things. And to show you that, we're going to use a fabulous tool called iperf3. So without further ado, let's get on to the data. So we're calling this one number 6, your network performance, or geez, where's my speed? Now I'll preface this by saying that if you are on a super WAM9 network where you've got 802.11 AC and the claimed 300 megabits of throughput, you may never have noticed this. Or if you're in a place where they sprinkle access points everywhere, again, you might never notice. But if you're sitting there with a couple of folks on a Starbucks network, or if you're at your home and everybody's streaming at the same time, you may have noticed. All right, let's remind ourselves about a couple of the differences between wireless networks and wired networks. Remember that when we're talking about how they work, we've got the access point, and it's got a lot of work to do. Nodes go to sleep, we've got the wired connection, and then we've got this whole switching between the point coordinated function, the contention-free period, and the distributed coordinated function, or the contention period. And that's where the nodes are actually trying to send data. We also have a lot more overhead. The header is bigger in a wireless frame, and every single frame has to be ACT. And then we may or may not be using the RTS-CTS exchange. We've got polling. We've got a couple of things that we have to get done when we're doing a wireless network. So the overhead is much, much higher. But worst of all, it's a shared media. And so we don't get the benefits of putting a doggone switch in there. Okay, so now that we've reminded ourselves about that, let's take a look at some of the data. Now in these tests, I'm going to be using iperf3. And iperf3 is an animal. It's fabulous for TCP. It sends data from one side or one node to another one. And here's some output of what that looks like. This one happens to be on a gigabit switch, and so we start with that one. But you can see that it's going to send a bunch of data. Now another important thing about the data that I'm going to show you here is that I never run one test. I always run a battery of tests and then take the average. And sometimes, if things really go wrong, I'll just throw out the test and do it again. Also, you got to be wary of outliers. Something may have occurred. So if you're really trying to get down and get your baseline data, that is how the actual network performs, you just got to be wary for things that are way outside the norm of performance. All right, so all of these tests will run at least 3 times, and then I'm going to give you the average. The 2 flavors of data that we're going to be worrying about here are the transfer and bandwidth. You see that at the bottom, or I guess at the bottom there. So it's going to be the amount of data that was transferred over 10 seconds and then the bandwidth that was allocated. And remember that we're going to be talking about gigabytes or megabytes in the transfer and megabits per second in the bandwidth, because we're talking about things that are 100 megabits per second or 1,000 megabits per second and so on. Now first up on the wired network, and it's a really simple topology. We see we've got a switch and then just a couple of nodes here. The difference is what kind of switch that is. Now in the first one, it's a fast Ethernet switch. That's 100 megabits per second. Now I will take a second here and I'll say that, look, you will never ever get 100 megabits per second or a gigabit per second. Why? Because you've got interframe gaps, you've got headers, you've got overhead. So you can never ever reach a throughput that equals the speed of the network. The best that you can get on an Ethernet network is around 96% throughput, or in the case of a 100 megabit switch, 96 megabits per second. In a gig switch, it's 960 megabits per second. So if you remember that, and then you go, okay, so what are we, how close are we to that actual maximum theoretical throughput? Well, this is a 100 megabit switch. It's a Cisco switch. It's not loaded by anything else, and it gets 94.27 megabits per second. Not too bad. Now again, there's nothing fighting for bandwidth there. And the overall transfer was 112 megabytes. Now the gig switch. very similar performance, but just times 10. Remember that a gig switch is going to be 1 gigabit per second or 1,000 megabits per second. And you can see here that the bandwidth was 937 megabits per second or 0.937 gig. Again, not too bad. Now, how do you compare this to wireless? Well, you can't really compare wireless to gig because it's just simply unfair. There are very few wireless networks that could ever hope to approach gigabit speeds, although we're trying to get there. So the early goal was to reach fast Ethernet speeds. So if you had a wireless network that was at 100 megabits or something over that, well then suddenly you had something that could compete with fast Ethernet. And when we think about when the early wireless networks came out, well, that's what the networks were at the time. Now the next thing that I decided to do was to say, all right, well what if there was competition? Now on a switch, it's not really a big deal, but if we want to talk about competition for wireless nodes, let's also talk about competition for wired nodes. So I threw another node on there. It was just doing a YouTube video. As you can see here, the topology. So we still have the iperf stream. We just have another one that's going out to YouTube. And we can see we had a minor dip in performance down to 87 megabits per second. Still not too bad. You would probably never notice it on a wired node if you had an 8% drop in your performance. But that's the wired side. I didn't bother to do it on the gig switch. Well, we know how the wired side worked, right? A fast Ethernet Cisco switch and a gig Ethernet Cisco switch. Let's talk about the wireless side. So this is a Linksys EA7250. So it's not too bad. I set it up for 5 gigahertz and 802.11ac was enabled. The security that was on there was WPA2. And so that adds a little bit of overhead because we do have to encrypt, and we were about 20 feet from the access point. So a very, very commonly seen scenario. Just a pro tip, take a site survey and see what the other networks around you are doing. We've got some 2.4 gigahertz networks around here, so I moved to 5. All right, so I did a quick check on nodes, but you know, nothing scientific, and it said that there wasn't very much in the way of competition. So really this is what we get. We have 2 laptops that are wirelessly connected to the access point, and we're going to send data between them. So what happens? Well, we get 105 megabits per second. Not too bad. This actually is an improvement over fast Ethernet. What? Yeah, so that was the goal. So I'm happy, right? The network works pretty well. No big deal. I would probably not notice any performance differences between my wired and my wireless networks. By the way, if you have a 100 megabit connection and then I give you a gig connection, you would probably never notice that either. All right, so at this point, the wireless network is holding its own. But then we add some wireless competition, and this is where we get into that whole contention problem, right? In the case of iperf, we have 2 nodes out there. They're sending data back and forth. It's not going to the wired network. The access point doesn't actually have too much to do. They weren't in power saving or anything like that. But the minute we add another node, we've got that contention period being jammed up by a couple of nodes. Take a look at what happens when we add one more node doing a wireless stream. The bandwidth drops down to 32 to 39. Now that range is in there because I did the test a couple of times. It's a huge impact. 70% reduction in performance with just one other node on there. Now, granted, it's doing video. It's not doing email, and it's not browsing the web. It's doing video, which is heavy duty, and iperf is heavy duty too. So the access point is being slammed. And so there are a lot of factors that can affect the performance of this. But 3 nodes on the network together, and we have a 70% reduction in throughput and bandwidth. Ouch. So we put the whole thing together, and we can see the numbers. And there's that wireless with competition. Now before that, wireless is doing pretty well. So if you have just a couple of wireless nodes on the network, and they're not doing too much, you're not going to have a big degradation in performance. But when they start doing heavy-duty data, well, we can see the impact of that. And based on the last couple of videos, we know exactly why that happens. Overhead, contention, shared media, all of those problems. So, wireless ends up losing, and gigabit Ethernet wins, of course. and fast Ethernet starts to look pretty good again. Now, was this scientific? No, not really, but it wasn't terrible. You know, I took a look around and did try to isolate the networks as much as possible, and I did it at a time when nobody else was using our network here. Now, I'm going to go over this in the next video, but there are things that you can do to improve your network performance. Do a site survey, take a look at channel use, think about other nodes, background processes, and things like that. And hey, you don't have to believe me, run your own test to see what's going on. So, testing your network is a really important thing to do. I encourage everybody to do it all the time and do it under load, do it under different conditions. But now that you understand more, especially when we get through channels and you know, overlap and things like that, we'll really be able to design our network and set it up so that it's, you know, the best performance possible. Investigate those conditions, find out what's around you, and you'll guarantee the best possible network you can. Well, hey, thanks for watching, thanks for listening, subscribe and like if I help, and may those wireless packets always reach their destinations with the best possible performance.